All right. So as ChatGPT says, identifiers in Java are simply the name given to something in your program, like class name, variable name, method name, package name, and interface name. We will have more understanding on what are these things, what is a class, what are variables, method, package, and interfaces in detail later. But here's some examples and some rules that we have to keep in mind. For example, it can contain A to Z lowercase or uppercase. It can contain 0 to 9 digits. It can contain an underscore or a dollar symbol. But apart from an underscore and dollar symbol, it cannot have any other um, special characters, right? So there are some examples that depict how we should name our variables or our identifiers. For example, 1 ABC, no, 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 we can't use like this. ABC1, yes, 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 it's valid. Okay, we have age and capital age. These both will be treated as different because Java is case sensitive. So capital A for age will be treated different variable if there is another variable age with small a. Okay, and they both are correct. We can have class, no, because class is a keyword. What is a keyword? We will get to know about it in few minutes. But we can have my class because my class is not a keyword. All right. So we can use my class 1, my class 2. Okay. Anything like that. We cannot have my hyphen name. No. Why? Because hyphen is not allowed. Only underscore and dollar are allowed. Okay. So yeah, my underscore name, good. Dollar salary, good. Then how should we exactly write a valid identifier name? For example, if we need to write a variable name, then without any spaces, okay, we will not use any spaces. What we will do, we will keep our first letter as small character or small case, okay, or we can say lower case. Then as soon as my first word is completed, then in the beginning of every next word, the first letter will be in caps lock or in uppercase, I can say. Then again, the remaining part of that name will be small case. Only the first letter will be capital, the others will be small case or lower case. Okay. Similarly, if you want to use underscore, you can use underscore or dollar in the beginning. Okay, but if you want to use numbers, numbers are allowed, but remember, not in the beginning. Okay, that will become invalid. So you can in between or at the end you can use numbers also. So this is how you can write variable name with number also. Okay, some invalid ones. Why? Because it starts with a number. Here, why? Because it has an hyphen. Int public, no, because public is a keyword. Okay, it's a reserved word. User @ID? No. Why? Because @ is not allowed. Only underscore and dollar are allowed. All right. So what are the best practices for variable names and method names? We use camel case. See, camel case means first word completely in small case, the second one in regular, or we can say the first letter in caps for the second or another words. All right. For example, I have to make a little longer variable name. For example, my name value is okay. So you can see I get my first word completely in lowercase and the other following words all have the first letter as capital. Name N is capital, value V is capital, and is I is capital. So this is how you are going to name your variables and method names. Okay. Then if you have to write the name for classes and interfaces, use Pascal case. In Pascal case, we have each word first letter always in capital and remaining as small. So for example, Pascal P is capital, case C is capital. So you can understand the difference between camel case and Pascal case now. Okay. For example, This is my first tutorial. Okay, so if I have to write interface name or class name, I will write like this. But if I have to write the variable name or method name, I will write like this. That's the difference. Okay. Avoid starting identifiers with underscore or dollar unless absolutely necessary. It is allowed, but we don't do that. Okay, in general, it is in rare case only. Use meaningful names. Please don't put like C, D, X or anything like that. Use proper names which will be self-explanatory as what kind of value it is going to store. For example, string name, int age, okay, anything. For example, like in essence to more such variable types, we can say double amount, okay, or fees, okay. So this is how you declare the variables in Java, okay. Or if you have to make multiple words in a single variable, so string student name, all right. So it's a camel case, get it? Okay, so this is about the identifiers in Java. Let's see what are keywords. Data types in Java, okay. So this is the list of keywords in Java, okay. And you can see keywords are reserved words in Java that have a predefined meaning and cannot be used as identifiers. That is variable name or method name or class or interface name or package name. We can't use them in any other way. We only have to use them with the predefined method, or we can say predefined definition of these keywords, okay. So, and out of these, const and goto, these are not used anymore in Java 8 or further versions, but the remaining ones are still in use, okay. So this is the list of keywords now, and these are the data types. Data types again are keywords, but they have like some special meaning. What that means is, if you are going to store some value, okay, in the memory, or memory means RAM, okay, random access memory, which is in your machine, your laptop, okay, or in your computer. So those values will be of a specific type. Maybe it will be an integer, okay, some kind of number. So number can be a integer, number can be a long, number can be a float or a double, okay, or a byte or a short. So what does these things mean? Let me give you a brief understanding on that. So you already probably know, if you are from the computer science background, maybe if you are doing BCA or BTech, okay, or anything like that, BSCIT, all right. So any kind of such bachelor's degree, or if you have gone through some internet content like about how computer works internally, so you must know that computer always operates on bits, okay. Bits are like 1001, something like that. So these are the bits. Computer does not understand our English language. It understands the language of machine. It understands the language of bits 0 and 1. Okay. So when you use byte, so it's like byte, um, and you can say like age. Okay. And this age can have any integer value in it. For example, age equals to 12. Okay, so age can have any integer value, but it cannot cross the 8-bit size. Okay, so at 8-bit size means the maximum bits that can are allowed is 8. 1 2 3 4 5 6 7 8. Now if you see, if I convert this value, this is 8 bits, okay. If I convert this bit into decimal number, let's see what does it say. See, 255. That means the maximum number that the byte can store is 255. If you need to store value more than 255, then what would you need? You need short because it is 16-bit. If you need more than that, you will go for 32-bit. It can store more longer, or we can say more larger numbers. So you go for int. If you need to store a value which is larger than the range of integer, then you store the value in long, and this is 64-bit. You already know that today most of the processors and computers are coming in 64-bit. So this supports long supports 64-bit processing of data, or we can say the values. All right, so here are some examples also coming. If you will try to store 1000 in byte, it won't store, it will give you error. Okay, error is something like you have some error, you have some problem. Okay, it cannot store that big amount or that big number in byte, in just 8 bits. Okay, so you must store that in integer, or we can say int. Okay, similarly, now we have char for storing the characters. The default value is like this, which is and for example, if you want to store a, b, small b, anything like a to z, or even numbers, anything, even small special characters, if you want to store, you can store in char. For example, char and sorry, alpha is equals to a. Okay, you can store like this, or a. Okay, then if you want to store symbol, I'm just giving any meaningful name to the variables. These variables are just identifiers. I can give any name, but I'm giving meaningful names, so you would also relate. So for example, if you wanted to store hash or dollar, okay, but see, if you try to store multiple values like this in single quotes, it won't work. Okay, it will give error. It can only store one character at a time, one char at a time. Okay, so dollar, or let's say if you want to store number, again you have to use single quotes, and inside that two, you see, int num is equals to 2. This is how it's different. Okay, if you are storing number, it's better you don't do that in char, you do that in int. Okay, then we have boolean stores one bit only single bit. It will be either true or false. Okay, either 0 or 1, like that. Okay, so all these are the primitive data types. Primitive means they store only particular bits in the primitive size. Okay, now we will go for the non-primitive data types, which store the value in references. For example, string, it is a class. Arrays, arrays is like composite. We can say like it stores multiple values in a single variable name. Okay, the variable name is single, only one variable is there, but we are storing multiple values. You remember I told you char ch is equals to 2 is allowed, but 2 is not allowed. Okay, but if you need to store multiple values in ch, what you will do, you will create array of character, है ना? Then in single quote 2, again 2, anything, any number. Okay, if you want to store for int type, just put data type as int. If you want to keep numbers, you have to remove the single quotes. Okay, now this is not character, this is number. So this is how the non-primitive types are working. Any class name, even if you create your own custom class, string is a predefined class in Java, but if you want to create your custom class or interfaces like employee, animal, anything, these will become non-primitive data types, enums. Okay, we'll read about all these things in detail. So these are the two different data types. One is primitive and one is non-primitive. The primitive ones are, again, let's repeat: byte, short, int, long, float, double, char, boolean. The non-primitive, any class's name, for example predefined class, or it is your own custom class, then arrays, interfaces, enums. Okay. All right. So now that we have come to know what are data types and what are the two categories, primitive and non-primitive, let's see the type of values it stores. In that way, what are the different categories possible? So we can store numeric values in integral data types like byte, short, int, long, and char also. We can store numeric values in floating point, like some decimal values if we have, so it can be stored in float and double. If we have to store non-numeric values, then we can store it in boolean. Okay. And there are some user defined reference type data types, for example class, interface, enum, string, and array. So here is a demo example that we have got. Let's try to run this. All right, I will change the file name to demo. So this is demo.java. If we need to create any file in Java, so it will always have an extension .java. All right, you can see here it says .java. Okay, then we have a public, class, and demo. You see, the public is a keyword, class is a keyword, static is a keyword, void is again a keyword. All these are keywords. These are not any variable names. Okay, these are all keywords, so they are reserved words. We can't use them in the variable name. We will try all these things here. We will try all the experiments here. So let's see. So public class, and then this is the class name. Okay, public class, and this is the class name. Class name is a identifier, and as we already have learned that a class name, an interface name, these kind of identifiers always use Pascal case. Okay, in which always the first letter will be capital and the following will be small. Okay, for example, if we have to write demo example, so we will be writing like this. Okay, e will become caps, but for now I have just kept it simple with single word demo. So d is capital and the one remaining one will be small case. After this we have to write a method is like function. Okay, in which we will define all our business logic. Okay, whatever the code we have to write, we write inside the method. So let's see. Again, like we have int, which is a data, it is a keyword but it is a data type also. Okay, a data type will always be a keyword. No, sorry, a primitive data type is always a keyword, but all the keywords are not data types. You have to remember this. Okay, so it will store age equals 25. So 25 is the actual value that will be stored in the memory. That memory will be referenced with the name age. You see, if you didn't have a name, your parents, how they will call you, how your friends will call you. You are a person, you are the value, you are the object. But okay, and you are there in this world. But how does someone else know, or how does someone else call you? They call you by your name. So this 25 is the actual object, this is the actual value, this will be stored in the memory, just like you guys are stored in the world. But just like you have the name by which somebody can reference you, similarly all the values stored in the memory will have a reference, and those references will be known as the variables. Alright, so variable will use camel case. Okay, for example here is the camel case, but if there is any following word, then it will be looking like a camel case, otherwise it looks like a small case. Okay, so now you can see int age equals to 25 double. It can store double and float, they can store the decimal value. So you can see here is a decimal value 55,000 decimal 75, or we can say 75, 55,000.75. Okay, so this is a decimal value. We can't you put the decimal value in the int or int, short, byte, like that. We can't put 25.1. No, why? It says provided double, required type int. Okay, so age was int, age was of type int, but what we are providing, we are providing the double value, so we can't do like this. Okay, the non-decimal values will go in the int, long, short and byte. The decimal values will go in the double and float. Okay, all right. So here's the thing, the boolean value will always be true or false. Now you can't put like this. Okay, you can't do like that, that will be wrong. You always have to put it like this. Okay, char grade equals to a. What if I write b? It will say convert to string literal. That means now this is not a character. Character will always have only a single character value. Okay, if I say 22, wrong, but if I say 2, right. If I say a, right, small a, right, hash, correct, hash hash, wrong, hash at the rate, wrong. So now you know how characters work. All right. Now I will tell you, like, if we have to store multiple characters, instead of single quote, you will use double quotes. Okay, string, and it will be stored in the string type, not in the char type. String name equals to John. Doesn't it look similar to something like char name equals to, and something here like J, then O, H and N, right? So we can also conclude that set of characters go into the string type. Okay, so string is nothing but set of characters. All right, and it is a predefined class in Java. Similarly, we can use arrays. So int array, for creating the array, we need to have square brackets. Okay, after the data type, then variable name equals curly braces, then actual value with comma separated, and you see, did you observe, in every statement it ends with a semicolon. Okay, then only the new statements are coming. So these are the separators. Okay, there can be different type of separators. Separators are nothing but any symbol that separates two different statements or values. Okay, so these are the separators, semicolon, then comma. Okay, there will be coming more separators coming later that we will study, but you have to remember these are known as the separators. These are known as the data types. These are known as the variable. Okay, or we can say, in general, we can say identifiers. Okay, this is identifier, this is identifier, this is identifier, this is identifier. Okay, identifiers can be of class name, it can be a class name, it can be a array name, it can be any other variable name or method name. Okay, it can be anything. All right, so that's how we can store values in the different data types. Now we have to print these values. Okay, we have to print these values here. Okay, this is known as the console. So we have to print these values in the console when I run this program. So I will right click and I will run the program. Now you see, I see name is John. Okay, when I print name here we are printing. Okay, it doesn't get printed here, it is being assigned here. This value is being assigned here to name variable, and this name is being printed on the console through this statement, system.out.println. The point that you have to remember is system is a predefined class in Java, so the name of the system class will always start with the caps lock or capital letter S, then dot out dot println. Okay, we will understand why we are writing like this to print the values in the next video tutorial. But for now, just remember, if we have to print anything in the console, we always write like system.out.println. Okay. Then here we have put double quotes to print the string name, colon and space. After this, we have to add the next string, which is name, or any data type that we have to print after the string. We always can append it, or we can say concat it using the plus symbol. Okay, add it to the previous string. All right. So this is how all these values are getting printed here. You see, marks 0 colon space, and then whatever the value was at marks 0. 0 is like index. Okay, so we will know more about arrays in later values, but you can say 0 is the 0 index, this is the 1 index, or we can say 0 position. 0 position, 1 position and 2 position. In Java, the positions, or we can say indexes, always start with 0. Okay, so at 0 position we have 90, that's why it prints 90. All right, so that was about it. Now let me tell you a few more points. For example, I told you we can use byte also here. Okay, it won't give any difference. While if we run right now like this, it works fine, age 25. But what if I have put a larger value here? What does it say? You should provide int. Okay, provided value is int and we are using byte. Even for this also 2455, it doesn't take in the byte. What if I use short here? Yes, it takes in the short. So short has larger range compared to byte. But when I increase the range again, it falls short. Obviously it's short, right? So it falls short. Now it is not able to store this big value. Okay, it is out of the range for short data type. What we do? We'll use int. All right, let's see. For int, it's going out of the range now. Till here it was fine, you know, out of range. If I try one more thing, even 0, it goes out of range. If we have to store bigger value, we use long. Okay, this is going to store longer values. Oh yeah, but there is a catch. If you have to use long value to store the number, you always have to keep a capital L at the end. Okay, with the number you have to keep capital L at the end. Now you can store bigger values also, but also it has a range, so definitely we can't store any infinite value in this, but certainly it stores larger value in range compared to the int. Okay, so now you know byte is the smallest, short has more wider range, then int has much more wider range, and the largest range to store a numeric number value, okay, non-decimal number values, we have long in primitive data types. All right, and for long there is a catch that we always have to keep a L as a suffix after the number. Get it? Good. Now, so you would wonder, and anybody would wonder, like what exactly is the range of these data types, like byte, short, int, long. What is the range of these data types? Let's check that out. Let's see. So byte, it stores 8 bits. So minus 2 to the power 7 to 2 to the power 7 minus 1. Okay, so it can store value which comes in this range, minus 128 to 127. Okay, short, it will store value between minus 32,768 till 32,767. Int goes even beyond that. Okay, and long, OMG, I don't think we normally would store such a big value, but here's the range. But you might not remember this range value, so you can remember this also, minus 2 to the power 6, 2 to the power 6 minus 1. Okay, so that's how it works. If you can't remember that, just remember this particular uh, formula: minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay, this is power, and this is minus 1 from this value. Okay, so that's how it works. Now in the next video we will learn more about operators and how to evaluate different type of expressions. Okay, we will also learn in the next video on different type of operators, and apart from that we will try to cover as much as possible for control statements also. Okay, thank you, and if you liked this video, please subscribe and press the bell icon. If you have any feedback for me so that I can improve in my coming videos, please let me know in my comments. Thank you.